Yes, ma'am, it is
Yes,
clear.
ma'am. Okay. So let's start with the networks. We discussed about the communication aspect in the last class. Now, what is a network? A network is the connection, interconnection of a set of devices capable of communication. So, according to this definition, a device can be a host, that is an end system like a telephone system or your laptop or your desktop, and it is sometimes uh, it can be a large computer, it can be desktop, workstation, cellular phone, or security system. So device, this definition can be a connecting device such as a router, which interconnects or connects a network to other networks, a switch, which connects devices together, a modem, that is modulator, demodulator, and which changes the form of data, and so on. So, in a network, the connection can be between the connecting devices, uh, set of host devices or the end systems, or it can be a combination of host and connecting devices. So any combination of hosts and connecting devices is a network. So when we connect two computers at home using a plug and play router, we have created a network. That can be a small network, but it is also a network. So while designing a network, we should have a set of criteria which are most important to the design of the network. The first is performance of the network, then reliability of the network, and the security of the network. So keeping in mind these three these parameters, these criteria, will design a network. So the performance of the network, it can be measured in two ways: the transit time and the response time. So the transit time is the response is the amount of time required for a message to travel from one device to another. Now, sometimes you must have seen that while communicating over a network, maybe a cellular network or a normal network, the point to point network, we get some delay. So that delay would be due to the transit time. So that depends on what type of a network you have designed. So our aim should be that the transit time and the response time should be minimized. Then the response time is
Ma'am, what is cellular network?
transit time.
Ma'am, cellular network.
Cellular network is your mobile network basically. When you must have heard about the Tata Indicom and the Reliance networks earlier when you have CDMA devices. Did you remember the old pattern of the mobile devices? Those devices, the Tata Indicom devices and other devices, earlier cell phones, your mobile phone is also known as cell phone. Now, hello, students,
Yes, ma'am.
Yes, ma'am.
is it audible?
Yes, ma'am.
Ma'am,
Yes.
your voice is quite low.
Okay. Okay. A cellular network is basically a network of mobile devices because I'll just give you a brief idea about cellular network. Why we call mobile networks or mobile device as a cell phone? We call mobile as a cell phone. Earlier we used to call it a cell phone because the frequency ranges of mobile devices, the frequency is divided in based on the geographical area, and that geographical area was divided into hexagonal cells for efficient transfer of the signals in the particular area of a mobile network. So that's why we call it as a cellular network. Got the point?
Yes, ma'am.
Yeah. So that cellular network is basically a mobile network. Earlier we used to call a mobile network or a mobile phone as a cell phone or a cellular network. So basically the transit time is the amount of time which is required for a message to travel from one device to another in the network. So that is transit time. Then response time is the elapsed time between an inquiry and a response. Suppose you submit an inquiry to a website or maybe some app, and the response it gives back to you, that is the response time. So transit time is the time your response or an inquiry took to travel from your device to the server, and the response time is the time elapsed between the inquiry, submission, and the response arrival. So the performance of a network depends on a number of factors, including the number of users, the type of transmission medium, the capabilities of the connected hardware, and the efficiency of the software. Now, suppose you're using a 3G mobile network or your 3G mobile network and a twisted pair for transmission medium. We'll discuss all about these things, transmission media and all these things. So if you're using an old network with the 3G capability or 2G capability, then your data transfer will be less. So it will take more transit time and more response time. So the efficiency also depends, the performance of transit time or the transit time and response time also depends on the number of users. Now you must have seen nowadays that the Airtel network or the Jio network, the number of users is growing. The number of users is growing, and because of that, the performance of these networks are also declining. So now, earlier you used to have only 2 Mbps or 10 Mbps or maybe 20 Mbps of speed, still the data rate and the speed, but still you were able to access it. But now as the number of users is growing, you have the fast data speeds, 100 Mbps speed, 50 Mbps speed is also common nowadays. Now again, capabilities of the connected hardware. Now suppose you have increased the speed of your network, you are having a 5G network, but still you are using a hardware that is a mobile device or a laptop which is 2G or 3G, which is only capable of transmitting using 3G technology. Then the connected hardware is also responsible for the bigger transit time and the response time. And then the efficiency of the software. Now you must have seen that the earlier softwares, they were very slow and they used to have a different data format for transmission of data. Nowadays you have advanced apps which can transmit the data in a faster manner. So the performance of a network, when you're designing a network, it depends on all these factors, not only on the transit time and response time you are measuring the performance of the network, but the performance also depends on multiple factors and all these factors. So it is also evaluated based on the two criteria, networking metrics, throughput and delay. Now, how much delay are you getting after submission of your data? In how much time you are getting the response back? So basically, the criteria are contradictory because throughput means how much input and output you can do. Suppose I have inputted 10 queries, I have done 10 queries, and you are getting the response of all the 10 queries in less time. The throughput is how much input output is being done. So if you send more data to the network, we may increase the throughput, but we may increase the delay because of the traffic congestion in the network. Now, if you consider suppose a new flyover or a new road is being built. Now, suppose DND. Suppose you have designed this DND flyover, Delhi, Noida, Delhi. So suppose you thought that more number of vehicles will go through DND. So you design that DND flyover because of for increasing the throughput, the number of vehicles that can go through that, number of vehicles that can transit through that DND in a day, or number of vehicles that can move through that flyover in a day. That is throughput. But if the number of vehicles, the number of cars and bikes and buses will increase, if you will increase the throughput, what will happen? The congestion will occur, and in effect, it will cause delay of the transit. So then if you will increase the throughput, the delay will increase. This is basically these two are contradicting factors. So you have to balance, whenever you are designing a network, you have to balance these two factors. If you're increasing the throughput, that is the data which you can upload on the network, or that data that you can download from the network, you are increasing the throughput, then it will increase the delay also, because it will have congestion on the network because of the increased throughput. So these have to be balanced. Now, next factor is accuracy of delivery. Network reliability is measured by the frequency of failure, the time it takes a link to recover from a failure, and the network's robustness in a catastrophe. Now, suppose you have installed some 4G network and you have asked some, suppose fiber network provider to install a suppose Jio Fiber, Airtel Fiber nowadays, which are very new technology in India. So if you have asked someone to install some network, wireless network or wired network at your home, and somehow that goes down because of a failure, suppose the power goes down, so that was connected to your normal power switch, and suppose you don't have an inverter at home, and that was not connected to the internet, this inverter, then what will happen? That switch or router, that device will go down, the power will go down, and it will be a failure. The network will disconnect. But how fast, if the power comes again and electrical power comes again, and it will again be started, the switch is again switched on, then in how much time your device will come back to the normal situation and it will start delivering the data accurately. So that is reliability of the network you are designing. So whenever you are asking for some network to be designed, you have to take in mind that your performance should be good in terms of transit time and response time. It should have a good throughput and less delay. It should be reliable, so that in case of a failure, any kind of a failure, maybe a fiber network is disconnected due to some intermediate switch at the service provider's end, or it may be a power failure. In any condition, if it comes back, in how much time it comes back to the normal condition, that is the reliability of the network. Next is security. Network security issues include protecting the data from unauthorized access, protecting data from damage and development, and implementing policies and procedures for recovery from breaches and data losses. You might have seen, if you were, I think you were too young, you must have heard about cable TVs. Have you heard about cable TVs, all of you?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So when we were kids, that was very at the peak of the technology was at the peak, and cable network was very new when we were kids, around 7-8 years old or 10 years old. So that time you must have heard that some people they didn't pay for the cable network, but what people used to do was they just cut the cable in between from their neighbor's network, and they just tapped onto that cable network, and they used to get the signal in their home, in their TV. Have you heard about all these things? Have you heard about these things?
No, ma'am.
No,
Yes.
ma'am.
The only thing was that was a small cable which was running from the service providers, cable service providers office to your home. And the people, those who, because they think they can just tap into that cable network by just cutting that cable a little bit and tap their own wire, own cable on that, and then they could connect that cable to their TV. So the whatever movies and whatever programs you need to watch from the cable network, they were not coming on Doordarshan or Metro TV from the national television channel. They used to watch those movies and extra things which were coming on the cable from by just tapping onto the cable and having it on their television. So that was just security breach. So that was just for the entertainment purpose. But just realize the severity of this thing, that if some hacker, if you are using those cable networks for basically transmitting some confidential data to defense or some ministry, defense ministry, then what would happen if a hacker taps onto your cable network, and that can extract the data which is coming on the cable, and it can view everything which is being transmitted on the cable. So that was a security issue in cable networks. Nowadays, you must be hearing about fiber network, all these Airtel fiber, Jio fiber, ACT fiber network, and all these fiber networks. So it's not easy to tap into these fiber networks, because it's not easy to tap the optical fiber information which is coming in the fibers. That we'll discuss later when we'll discuss about the transmission media. Okay. So basically, we should be aware how much secure is our network while designing a computer network. We should take care about all these things. Now, physical structures. Based on the type of connection, we can have two types of networks, or two types of connection we can have for network design. One is point to point, another is multi-point. Point-to-point network is basically which provides a dedicated link between two devices. Suppose now if you want to call a friend, you can have a dedicated line so that it is available 24/7 to you only. So you can have a dedicated telephone line or a dedicated link between your device and your friend's device, so that anytime if you want to call your friend, she can only pick your phone and you can call that friend. So the main advantage of point-to-point links for networks is the entire capacity of the link is reserved for transmission between these two devices. So most point-to-point connections use an actual length of wire or cable to connect the two devices to ends, but other option is microwave satellite links are also possible. Now suppose you want to have a dedicated link to your friend's home, and you want that anytime if you call there should not be any congestion. So you can have a direct wireless connection, microwave connection, or satellite connection also, or maybe a telephone line to connect to that friend. So when we change television channels by infrared remote control, we are establishing a point-to-point connection between the remote control and the television's control system. This is one example of point-to-point. When you are changing the channels, you are changing from the remote and you are controlling the television control system. So there is a point-to-point link between the remote control and the television control system, which is just being regulated by the remote control. That is a point-to-point link between. That is infrared. Have you seen that you cannot control your TV through remote control or your AC through remote control beyond 10 meters distance? Have you seen that?
Yes, ma'am.
Yes, ma'am.
That is because your remote controls are working in the range of 10 meters, not beyond that. So that is point-to-point link being established between the remote control and the television. Then multi-point is, or it is known as multi-drop connection, is where more than two specific devices share a single link. Now you can see these two pics. Point-to-point link is two laptops or any two devices connected with a direct link between them. And multi-point is where there is a single link coming from the main frame and all the devices are having a tap, which is tapped into the main link, and they can connect to the single multi-point shared link. Now in a multi-point environment, the capacity of the channel is shared either spatially or temporally. If several devices can use the link simultaneously, it is a spatially shared connection. If users must take turns, it is a time shared connection. Now, what do you mean by temporally? That is time shared, and spatially shared connection. Spatially shared connection means that the entire capacity of the channel will be shared. Now, if I say the total bandwidth, you must have heard about the Wi-Fi devices nowadays. If you have a Wi-Fi connection at home and suppose you are just using it for your mobile only for a single mobile, you're just accessing that Wi-Fi connection with a single mobile device, then the entire 100 Mbps or 30 Mbps or whatever the data rate of your speed of your Wi-Fi connection, that will be used by your phone. But suppose your siblings also come, your parents also come, your cousins and your neighbors, all of them are using the Wi-Fi connection at your home. What will happen? They all will be sharing that using a multi-point connection. This is basically for the wired connection, multi-point. But when I am talking of the Wi-Fi router at your home, and when all of them are connected through Wi-Fi connection, then also that will be a multi-point. So the entire capacity, 30 Mbps or 50 Mbps, whatever is the data limit of your Wi-Fi router, that will be shared among all the, suppose now your 5 family members or 6 family members, suppose 5 family members, and the data rate is 50 Mbps. Then 50 Mbps will be divided equally amongst the 5 mobile devices. Then the data rate and the speed will decrease to 10 Mbps. So 50 divided by 5 is 10 Mbps. So that is multi-point connection, multi-point link for Wi-Fi connection. So that is spatially shared connection. Now suppose if you suppose you are 3 siblings or you are 2 siblings, and you say, I have a class now, and I want the total capacity, I want 50 Mbps for my class, because I have to turn on my camera also for my class. I have to turn on my video also for the class, and I cannot survive on 25 Mbps or maybe 10 Mbps if I have to do my class. So you need entire 50 Mbps of your Wi-Fi connection. What will you do is you'll do a tie with your sibling. Suppose you have a brother at home and he wants to play some online game with his friends. So he also says, I need 50 Mbps data of the entire Wi-Fi connection, and I also want a high-speed connection. So you can just tie up with your brother temporarily. You can do time sharing. You can say, I have 1 hour of class now from 12 to 1, and I'll be using the 50 Mbps. You don't connect to the Wi-Fi now. You just switch off your Wi-Fi. So that time, 1 hour, you will be using the entire capacity of your Wi-Fi, 50 Mbps, that is time shared. And after 1 o'clock when your class is over, you can ask your brother to log into his online game and he can connect to the Wi-Fi, and then you can switch off your Wi-Fi connection and Wi-Fi, and your mobile device will not be using that 50 Mbps of data. That is time shared. So temporal is time, or temporally shared or time shared connection is same, and spatially is when you're sharing in the same space you are sharing the data. That is spatially shared connection. Then physical topology can be defined based on how the nodes are connected, or the end devices are connected in a particular network. There are physical topologies are mesh topology, star topology, bus topology, and ring topology. Mesh, you know, what do you mean by mesh? When every other node is connected to any other node. So suppose you are 5 friends and you're connected to this, you want to connect to each other, and you don't want, if one person is not available and his or her device is not working right now, or suppose the mobile device of that person goes down, or the laptop of that friend goes down, then in that case you don't want that all other 4 friends communication should be disrupted. What you can do is you can have a point-to-point link to each other friend, all the friends. So when every device is connected to other device, so there are n-1 links. Suppose you have 5 friends and you want to connect to each friend. Suppose as a person you want to connect to other 4 persons, then you will be needing 4 different connections. Similarly, other 4 people will be requiring 4 connections each. So that ways n into n-1 connections you require, and if every connection is full duplex mode, then it will be n into n-1 by 2 connections. So basically this mesh topology is very nice, but the disadvantage of mesh topology is that it requires n into n-1 by 2 duplex links for connecting n devices. So when the value of n increases, the number of connections and the number of wiring or the number of ports you require for input output will be increased. So mesh offers advantages. The first is the use of dedicated links guarantees that each connection can carry its own data load. That means you can use the full capacity of the link. If it is 10 Mbps, you can use 10 Mbps. It is 50 Mbps. The entire capacity of that data link can be used fully by both the parties. So thus eliminating the traffic problems that can occur when links must be shared by multiple devices. So like in multi-sharing environment, you don't want to share the link capacity, then the traffic can be avoided in mesh topology. Second, mesh topology is robust because if one link becomes unstable, it does not incapacitate the entire system. So if one wire is down, or if one link is down, you can communicate over other links with this mesh topology. Third, there is an advantage of privacy or security. So if you want to communicate something to one friend only and you don't want to communicate it to other friends, you can send it on the private link. Then finally, point-to-point links make fault identification, fault isolation easy. So basically, when you are discussing about the point-to-point links, you know when your data communication is disrupted on a single link, you can identify that there is a fault between this links, single link only, and you can isolate that fault, and the rest of the system, rest of the network can be in the normal running mode, and the traffic can be routed to these links, these extra links which are running normally, and they can be the suspicious routes can be avoided also. this is an example of a mesh topology with 5 devices. So you can see these are 5 devices. This device, it wants to connect to 4 other devices. This will have a dedicated link to the first one, the second one, the third one, and the fourth one. Similarly, every other device will be connected from a point-to-point with the point-to-point link to other device. Now, main disadvantage of mesh topology, as we discussed a few minutes back, are that the amount of cabling and the number of I/O ports required. Now, if I just want to connect to 4 different devices with a dedicated link to all other devices, if I want to connect to these 4 devices, I'll be needing 4 input-output ports or 4 ports to connect to these devices. So I won't be having so many ports on my laptop or my device. So that is the major disadvantage of this mesh topology. And then the amount of wiring and the cabling required will be more. So if you want to have a dedicated link to suppose 10 devices, you'll be having 10 ports on the device, and you will need to have 10 cables out of each laptop or each device. So you can imagine if there are 25, even 25 devices which need to be connected on a mesh topology, you'll be needing so many wires and you'll be needing so many ports on your device. That's really impossible to have that bulk of wiring that is required for mesh topology, and these many I/O ports you cannot have on the hardware also. So that are the limitations of mesh topology. Now, one practical example of mesh topology is connection of telephone regional offices, in which each regional office needs to be connected to every other regional office. So you must have seen the telephone exchange, which used to have earlier telephone, the normal landline telephone exchange. In those cases, in those days, we used to have the mesh topology, and every telephone exchange was connected to other telephone exchange using a mesh topology. So all the regional offices were connected through a dedicated point-to-point link. So that is an example of mesh topology. Then we have star topology. Star topology, each device has a dedicated point-to-point link only to a central controller. Like this, you have a central device like hub, and all the devices are connected to this. So the communication between the 2 individual devices is not direct here, and all the devices will first send the data. Suppose this first device in this pic wants to send the data to other device. It will first send it to hub, and then hub will transmit it back to the second device. You don't have a direct communication between these 2 devices. So that is no direct communication, and the advantage is less number of wires is required. So if you want to connect 25 devices, suppose, then there will be 25 dedicated wires or connections to the 25 devices, and a single hub will be acting as a central controller for communication between those 25 devices or laptops or systems, anything. Now, unlike a mesh topology, star topology does not allow direct traffic between devices, as I told you. And if one device wants to send the data to another, it has to use the central controller, that is the hub. It is less expensive. As you can see, every device, it needs to have only a single port, I/O port, through which it will be connected to the hub. And if it wants to connect to other end devices, it needs to just send the data to hub, and it only requires one link. So the wiring required and the connectivity required is less, and a single port will do. This is very good, and it is easy to install and reconfigure also. Suppose you want to, if you have a hub of 16 ports or 16 connections. So, and already 8 devices are connected to the hub. You can do one thing. You can have another device and you can put it on a 9th slot of the hub, and you can attach 8 more devices to the hub. So installation and reconfiguration is very easy. So you can disconnect it from the hub and you can reconnect it to the hub anytime, and it is very easy to install and reconfigure. You just need a cable to connect to the hub, and you can unplug that cable, and it is easy to be installed. It is easy to install. So cabling is less cabling is required, and any deletions or additions and movements is easier than in hub. And other advantages include robustness. If one link fails, other links are still okay and they're still active. So there is the only thing is the big advantage is if the hub goes down, if this device goes down and there is something wrong with this device, then the connectivity between all the n number of devices connected to the hub will go down. Suppose you have a hub in your lab, suppose, and you have built a LAN using hub in your laboratory, your lab in the college. And if your hub goes down, the entire LAN will go down and no system will work and you cannot communicate with other systems in the absence of this hub. So that is the biggest disadvantage. Otherwise, you have to ensure the reliability of this hub. If it is reliable and it, in case of any failure, you have to replace it as soon as possible or you have to repair it as soon as possible. Then the bus topology. Bus topology, it is basic. So basically, the star topology and mesh topology, they are point-to-point connections. But bus topology is multi-point connection. As the name suggests, it has a single cable running from one end of the room to the other end, and it has the taps in between, equidistant taps, where you can have a drop line connected to the end systems. So you can see in the figure 1.6 that there is a cable which is known as a bus, and this bus will be shared by all the multiple devices which are connected to taps on the cable. Now, the disadvantage of this is basically when you are doing a tapping, you are connecting a tap to this cable. What will happen? The signal which is flowing from one end of the cable to the other end, the signal becomes weaker because when you're tapping, some energy is transmitted into the heat in the form of heat here. So when you are sending a signal from this end to this end, the signal becomes weak and you cannot tap, you will not get the signal at the full strength on every drop line. So when the signal is starting from this end, suppose this is the first drop line, this is the first system connected to this, the energy is dissipated here, the heat will be transmitted here and the signal will be weakened. So depending on the length of the cable, the bus cable, and depending on the number of taps which are connected to the multiple devices here, the signal strength will go down as a number of taps and the number of connected devices increase on the cable. So that is the biggest disadvantage of bus topology. So there is a limit on the number of taps a bus can support and on the distance between those taps. So you cannot do it on a smaller distance. You cannot tap the devices on a smaller distance because at every point, at every tap, the signal will become weak. Now, the advantages of a bus topology is, the biggest thing is ease of installation. Backbone cable, it can be laid in the room on the most efficient path. Where do you find basically room for the cable? You can just put a cable from one end of the room to the other end and just strap into all the devices and the nodes and the drop lines wherever you require. And suppose 1 meter distance or 2 meters distance, you can just plug in one of the devices you want to connect. And it uses less cabling in comparison to mesh topology and star topology because you will be needing only the drop lines, small drop lines and the taps only, and only a single cable will run from one end of the room to the other end. But what will happen, the disadvantage is it is difficult to reconnect and fault isolation is difficult. Why? Because if you have installed a tap here and a drop line here for one system or for multiple systems, and if you disconnect this device from here and you want to reconnect it at this point, some other point of the cable, already you have tapped and you have already weakened the signal here. So this tap cannot be repaired. This cable cannot be repaired again. And some heat will be dissipated here. Some heat will be transmitted here and the signal will become weak here. So if you disconnect this device from here and you will again have a tap after some distance here, a new tap, the signal will become weaker and weaker. So you cannot just disconnect and reconnect anywhere on the bus topology. So that is basically, that was easier to install because the cabling required was less. That was okay. And you can tap in into anywhere. But reconnection, movement, and addition is very difficult. And suppose you have already exhausted the capacity of the bus topology and you have already plugged in, suppose, n number of devices on the cable. So if you want to install one more device here, n plus one other device, that will further increase the signal capacity, signal strength, and that will not be possible in bus topology, and that will become difficult and the signal will be weakened further. So additions, movement, and reinstallation is difficult in case of bus topology, and fault isolation also is difficult. Now bus is basically easier to install, but the problem is degradation of the quality of the signal. Then ring topology. Ring topology is something like this in the figure you can see here. And the first thing is there is no point-to-point link in the ring topology. And all the devices are connected to a single communication line, the single wire, and they are connected in the ring form. Now suppose this is a single cable running and you can have a repeater everywhere. Repeater. Instead of taps, like in bus topology, you can have repeater here so that it can repeat the signal and the signal strength is regained and the signal is back to its normal strength. So you have repeaters here and all the devices will be connected to the repeaters on the ring. So it will have a ring-like topology. And if you want to send a signal or a data or a message from one, suppose this device, first device to the third device, you have to start from here and it will go to the second device, then to the third device, and it will move on the entire ring and it will come back to the first repeater or the first device. So basically a signal is passed along the ring in one direction from device to device until it reaches the destination, and each device in the ring incorporates a repeater because the signal strength has to be signal strength is to be it has to be basically on the same strength. Signals should come back to the same strength so that all the devices should get the data at a normal speed and a normal strength. It is basically as compared to bus topology, as compared to the mesh topology, as compared to the star topology, a ring is relatively easy to install and reconfigure. Now each device is linked to only its immediate neighbors physically and logically. So it needs only 2 points for communication. One is on the left side of the device, it needs to connect to this side of the device, and on the right side of the device. So left and right side, you need only 2 connections. But the only constraint is that the maximum ring length and the number of devices that can be connected on the ring. Because if you increase the number of devices on the ring, suppose I want to transmit the data to my nearest neighbor, this one. This device wants to connect the data to this repeater, second one. But it is not on the side of the data flow, because the data is flowing in clockwise direction, suppose like this. It is flowing on the clockwise direction. And you want to send that to your nearest neighbor on the anti-clockwise direction. So then in that case, it will take the time for the data to just cover the entire ring, the whole ring, and it will come back to this end device, the last device. So if you want to send the data to the last device, it will take time to for the data to float and to rotate throughout and it will come back to the last connected device on the ring. So the number of devices which are connected on the ring, if you increase the number of devices, the transit time will be more and the response time will be more because the data is only flowing in one direction. Fault isolation is simplified because suppose you are not able to send the data, then you can see if one device is not working, you can disconnect it from the ring and you can disconnect other devices on the ring and that device will come out of the ring and others may communicate after it is isolated from the ring. And it can raise an alarm after specified period of time if there is you are not receiving a signal from a particular device, you can just isolate that device. Now, unidirectional traffic is also disadvantageous because a break in the ring can disable the entire network. So suppose because the data is only flowing in one direction and if one machine goes down, the entire network will go down till the fault is isolated and the faulty machine is separated from the network. Then we have network types. There are two types of networks based on the geographical area they cover and based on the type of devices to which they are connected. Now, local area network, it is usually privately owned and connects some hosts in a single office building or campus. Like you, if you visit the college after this, the classes go in physical mode, then you can see there are 4 labs in the college and we have LAN in each of the labs. That is, our college is having multiple LANs which are connected to each other. That is a privately owned network. And all the networks, all the systems, all the desktops in the lab are connected to the LAN. So depending on the needs of an organization, a LAN can be specific to as simple as 2 PCs, a printer in someone's home office, or it can extend throughout a company and include audio and video devices. So like we have LAN in our department, in our labs, which is connecting the printer. The LAN printer also is connected. Make this all the devices in the lab are also connected. So depending on the requirement of the company and the user, you can have any type of LAN, any size of LAN. You can have 8 systems connected, you can have 16 systems connected to it or 32 systems connected to it. It depends on the requirement of the user. So in a LAN, basically every host means a device. So every device has an identifier, an address that uniquely identifies a host in a LAN. So when you will start working on the LAN in the lab, you will come to know that you will have a unique address, unique identifier through which you can detect that device. A packet sent by a host to another host carries both the source address and the destination host address. So suppose one machine on the network on the LAN wants to connect to another machine on the network, it can communicate using the address of both the devices. So sender's address and destination host address is also there in the packet. So you can see here a LAN. Basically, it was kind of a bus topology. It was kind of a bus in the earlier days, past decades. It was like this. There are several host machines. There are several machines and laptops which are connected to the LAN. Now we have, they were basically, earlier in our days, we used to have LANs using hubs in the star topology and or maybe through the bus topology. Nowadays, we have high speed switches through which the machines are connected and LANs are designed using the switches. Then we have wide area network. So usually when you are discussing about LANs, we have to take in mind about the wide area network also. Suppose Now, I have a LAN in my Rajguru College, or only one LAN in my Rajguru College. And if I just want to connect it to the university, and university also has so many colleges. So every college has its own LAN. I just want to communicate with some other host system or some other computer in the university department or maybe some other college. I want to connect the two LANs in two different colleges. So that ways I can connect to WAN. So wide area network is also an interconnection of devices capable of communication. And basically LAN is limited in size and it has a smaller geographical area. WAN has a wider geographical area, maybe a state or a town or a country or even the world. So when a LAN interconnects hosts, a WAN interconnects connecting devices such as switches, routers, and modems. So you can see here, there is one LAN here, one network here, suppose of Rajguru College, and one network in the university department, computer science department of the university. I just want to connect to these two LANs. So then also I need to have a connecting device, that is switch. So one switch will be installed in Rajguru College, another switch will be installed in the university department, and then these two, one LAN is connected to this switch, another LAN is connected to this switch. Then both the LANs will be connected to these two connecting devices, that is switching devices, and there will be a connection medium also. Now this connecting medium can be any type. This could be wired or wireless also, any type. So then when two LANs are connected, simple two LANs are also connected, then it will be a point-to-point WAN. And two LANs are also connected through the switching device. So when we introduce the concept of a connecting device between the two LANs, then there is a concept of WAN, wide area network. So then your geographical area increases for communication, for developing this network, and also the concept of a connecting device is introduced in case of WAN. Now, in case of, there are two types of WANs, point-to-point WAN, as we have seen in this diagram. The two devices are connected through a connecting medium, transmission media, and they are further connected to the LAN 1 and LAN 2 in two different colleges or two different departments of the university. Now, there is switched WAN. Now, suppose I want to connect all the colleges. There are LANs in every college, every computer science department of every college. Suppose there are 20 colleges with computer science honors and they are having their own LANs. And I want to connect all those LANs to the university also. So I'll be needing a switch or a connecting device to every other network. So there are switches for every LAN, and all the switches will be connected to each other. So all of the LANs in the university, in every college, will have a switch, and they will be connected to each other through either a dedicated link and the point-to-point link, or a wired media or a wireless media. And then those switches will have their own mesh network or any connectivity between them. And further, those switches will be having their connections to individual devices of their own LANs. So that is a switched LAN. Example of a switched LAN you can see. Now, internetwork. Now, internetworking is basically when you have a LAN or a WAN, they are connected to each other. It is very rare. So all the way when two or more networks are connected, they are an internetwork or an internet. So basically, the example I have given you for the switched LAN, that is an example of an internetwork. So a bigger WAN can be an internetwork also. So when we are using the example of all the computer science departments, LANs of all the colleges, 20 colleges of the University of Delhi, which are offering BSc Honors Computer Science, and they're connected through their routers and switches, and they're connected to each other, then they will form an internetwork. So a bigger network of WANs is also known as internetwork or internetwork. Internet. So suppose the book gives you an example. Suppose there is an organization which has two offices, one on the East Coast and on the other coast, West Coast. So if the office wants to connect the two LANs in two different regions or two different cities of the same country, or maybe on the continent, then it can use a point-to-point dedicated WAN through a service provider, and it can connect the two LANs. So you can see this. This is a switch which is connecting the first office and all the devices on the LAN, and this is LAN 2 on the left hand side with the switch and all the devices connected on the LAN. And then you can introduce the concept of point-to-point WAN, or you can have a connecting device known as router here. So if I want to send the data between these any two machines on LAN 1, it will go to the router, and router will see the address, destination address. If it is not from the same LAN, it will forward it to router 2 and to the LAN 2. But if it sees that the address is from LAN 1, it will go back to the same LAN and it will not forward it to router 2. This is internet networking. We'll see all these routing procedures and routing algorithms in further topics in the networks. Then switching. Now, when we are talking of networks, there is a concept of switching. How the networks send the data from one point to another, which are connected through the network, maybe a LAN or maybe a WAN. So there are two types of networks: circuit switch networks and the packet switch networks. I think we'll stop here. This will continue in the next class. I'll take attendance because it is time for your lunch break, and then we'll continue with the lab at 1:30. Okay.